Now, ladies and gentlemen, we are on our last 2-hour session. Welcome to the guys that's joining us via the live streaming. Thank you guys for being here. I know that it is the 4th day of your 5-day holiday. Okay? And welcome to those who's joining us. So sad that you guys didn't bring us coffee. Oh, no, it's fine. I won't take candy from a baby, you know. Okay? Just joking, please. Didn't mean anything discriminatory about that. Okay. Ladies and gents, while we are waiting for the influx of learners here, I want to quickly talk to you guys just about how today is going to happen. Today we are going to spend our time, going through geometry. But I believe today could be so much more. I know that some of you go and you look at geometry and you go, "Sir, I know. I don't like this section. I never see these things. When they prove this thing is a cyclic quadrilateral, you look at this and go, that means nothing to me." Okay? Is there a few of you that's looking at geometry that way? Okay, a little bit. Okay? I want to encourage you guys that geometry is most probably the most important section of work in mathematics. Making a very bold statement there. And welcome. Okay? And I don't say it lightly. I don't just say it, because I want you to pay attention today. No. I say it because I mean it. Because geometry, okay, I'm going to say another statement. The chances are you are never, ever, 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 ever going to use geometry in your real life. Unless you maybe build a house, or unless you maybe paint a wall and you want to get area, or something like that, you're never really going to use geometry again. But then why do I say it's the most important section in maths? Can someone tell me? Is there any of you that have always wondered, why the heck do we do geometry? I see a big smile here in the front. And when I look at my teacher and I look at them and go, why? And they go, because it's in the curriculum. And do you want to do well in maths? Then you do geometry. Guys, geometry is so much more than that. Geometry is not just about the work. It's about the way of thinking. It's about mathematical reasoning. It is about, can you solve problems? Now, we've already, on Monday and Tuesday, on Monday morning, our first session was about the monkey behind the mountains. Well, I talked at length about, look for the monkey, identify the problems that's in the way. But the issue is, ladies and gents, there's a very set thing that you need to be able to do before you can even go towards the monkey in the mountains. And that is the skill that's taught to you in geometry, if you pay attention. If you pay attention. So my encouragement to you guys today is to really think past just cyclic quads and circles and tangents and triangles and those kind of things. Think past that and look at the way that you solve problems, the way I approach a problem. Because whatever I do, whether it be on the projector, whether it be on the board, you'll never see again in your life. But it's a thinking that goes on behind it. Now, when you want to build a house, ladies and gents, it's like building a house. All of you hopefully would like to one day live in a nice house. And when I was as young and naive as you guys, sorry, shouldn't have said that. I wanted to have a big house. I wanted to have that house on the mountain. It's like double story with the, infinity pool, and all of these wonderful things. I wanted to have a house like the one on the right. Oh, that was wonderful, hey? It's beautiful house, manicured lawns. Until I owned a house and I realized I've got to do all the maintenance in the house. If I've got a lawn that looks okay, you can't really see how beautiful the lawn is, but I've got to mow that lawn and I've got to cut all those bushes to look the way it does, or I've got to pay someone to do it. I don't have the money to pay someone. I'm a teacher, okay? Don't have that kind of money. So I would like to have a house on the left. Am I right? I would like to have it. Some of you go, nah, I still want that house on the right. So that's fine. Forgiveness is free. Okay? But when you guys are solving problems, okay, and you are doing a maths exam, in your mind, you're building a house like that. You are solving all the world's problems, one math exam at a time, And you're building that thing. You're building this amazing house. But when you receive the text back, you realize that was actually what you wrote down. Now you go, sir, you insult me. No, I'm talking the truth. Because how many times have a teacher come back to you after an exam and asked you, please explain your logic? You go, wow. I kind of was just, doing my thing, I was writing down what was in the moment. I was stressed, And the teacher goes, no, I don't. I have no clue what you're writing down. You're telling me that angle is the same as that angle. Why? And you go, I don't know. Now, I've got a nice analogy, and it worked because it really happened to me this year. One of my grade 11 learners, after a cycle test, when we were writing about algebra and all of those wonderful things, he wrote down we asked him to maximize an expression. So you guys hopefully know, in that stage, we do it by completing the square. So he had this expression, y equal to negative x squared minus 4x, or y equal to negative x squared minus 3x plus 4. And I asked him to maximize this thing. And his first step, he does this. Okay, so he divided by negative straight through, if you're not wide awake this time of the morning yet. And what do I do as a teacher? Put a red pen through everything else he wrote down, because I don't care. You made a really silly mathematical mistake. You didn't just make a calculation error. You divided by a negative and there was no equal to naught. He got to the right answer. Somehow. Look, I don't know. I didn't understand. And he comes to me afterwards. But sir, I got to the right answer. I want at least 2 marks. It was out of 4 or 5. I said to him, go fly a kite. I'm not going to give you any marks. But sir, my answers are right. How can you not give me marks? I'm like, I don't care. Oh, yes, I don't care. But sir, no buts. But sir, the roof of my house is beautiful. It's nice and straight. But the rest of your house is falling apart. No, I don't care, sir. My roof is amazing. But sir, no. But go back to your class. I'm not giving you any marks. Okay, now it might sound a tad harsh, but when you get to varsity, that's how they work. I remember in my 3rd year analysis, I was really irritated. They ask me to prove something. In the third or fourth line of my proof, now an analysis proof is about 3/4 of a page to a page long. About 3 lines in, I wrote "and" instead of "or." And the teacher just circled it and put a red pen through all the rest. I think I got 2 out of 10. I went in a huff and a puff to this teacher. I'm like, but all the rest is right. And they said, but that one word meant that the rest doesn't make sense. But no bonus marks, no sympathy marks. That one word changes the whole dynamic of the proof. Now you go, ooh. So yes, I've got to pay attention to English in maths. Yes. Get used to talking maths. When you get to varsity, they want you to be able to explain. Now, ladies and gents, I'm not just here to tell you, oh, you are stupid. I would like to tell you, but how do I build a house? How do I, if you are constructing a house wrong, it doesn't help just walking out here and saying, you know what, okay, I'm building the house wrong. I would like you to, how do I build the house right? Well, where do I start with the house? You guys quickly tell me. The foundation. Yay, you guys are getting this right. Next, you go to the walls, the windows, and the doors. Lastly, we go towards the roof of the house. Now, here's the thing. A lot of you guys, when you are solving problems, you are trying to build a palace on the foundation fit for a shack. Ouch. That's a bit of a burn, sir. Okay, I'm going to quickly prove it to you. What is the definition of a circle? That's a dance move in some cultures, you know. What is the definition of a circle? A shape with no corners. Sorry, I'm just quickly constructing your circle. That shape doesn't have corners if I drew it correctly. It doesn't have any corners. So I've drawn a circle according to your definition. You guys starting to see that, whoopsie, I've been working with circles for 4 or 5 years, and I don't even know the definition of a circle. What is the definition of a circle? Now, let me just quickly say, don't feel stupid. I've done this exercise with about 4,000 kids this year. Okay? And only one guy has come about 95% of the way to getting it right. It's a series of interconnected points that are equal distance from a central point. It's a series of connected points that are all equidistant, equal distance from a central point. Now you might come and say, sir, do I have to know it? Yes, because if you don't know it, you don't know about radii. And if I don't know about radii, I don't know about half of the circle geometry you're talking about. In grade 12, I'm going to struggle with analytical geometry. In grade 12, I'm going to also struggle with trigonometry because we are going to apply all of trigonometry, not all, a lot of trigonometry to circles. And we're going to mix everything in grade 12. But if you don't know the definition, you're not going to know there's any radii. Okay, now here, I'm just quickly, okay, before I go too far in this. How does this relate to maths? Well, the foundations in maths is your definitions and axioms. Now, please, an axiom is not a skin condition. It's not something you get if you don't shower enough. But what is a definition? What is a definition of a definition? What is a definition? And please be careful, it's not a description of something. If I look at you, just like you are there, is that everything you are? No. I can describe you in all colors and all shapes and everything, but it doesn't make who you are. The same with shapes. Just by being able to describe a shape doesn't mean you can define the shape. Definition is what makes something what it is. An axiom is something we accept to be true. Like, what color did I use to write here? Purple. Or a shade of purple. You can go, oh, so that's lilac. Or that's more of a lavender kind of. It's still a shade of purple. Can I ask you to prove that to me, sir? No, not really. We kind of just assume it. That is an axiom. An axiom is an assumed truth. Like the interior angles of a triangle add up to 180. Did you go and measure every single triangle? No. Did I go and prove it? No. We just measured a few, and your teacher in grade 8 went, ta-da! You see, and then you assume it. The same with angles on a straight line. Add up to 180. We assume it. We never prove it, we assume it. That's an axiom. Okay? Now I'm going to do an allo lesson quickly. So I came here to do geometry. Now you've got to go, allo? Yes. Let me ask you this question. And I'm going to get very deep, very quickly. What defines you? If I take away your school, your friends, your family, your possessions, your sport, your boyfriend or girlfriend, or both, I'm not discriminating, okay? Your religion, what is left? Now, some of you are looking at me going, there should be something left. But guys, according to Dr. Miles Monroe, one of the foremost trainers and teachers on leadership and developing your own potential, he says it's the biggest question that has haunted mankind since the start of time is who am I? Has any of you had a dad that has lost his job? Does any of you have a dad that has lost their job? Been retrenched or fired? My question to you is there in the back. How did that shake your dad? It shook him to his core, right? Guys, it happened to my dad 5 times. Every single time, my dad was shaken to his core because for a man, first thing you get around the fire, when you've got a nice braai around the table, if you meet someone new, hey man, what do you do for a living? It's so central to who a man is that I am pleased not equating it, but in a man's life. Ladies, it's the same thing as you getting the news from a doctor that you can't have kids. It's equivalent in a man's world to a lady's world. If that doctor one day calls you and says, I've got bad news, your body has just given up, you cannot have kids, it shakes you to your core. Because since you were yay high, you start playing with dolls. You start thinking, you know what, if I get married one day, you know what, I'll playing, baby, and when, you're laughing at this, but it's central to who you are. Believe you me, I know that because me and my wife went through it. We lost a little one. It was a miscarriage. It shook my wife to her being because we connected directly to who you are. And society connected directly to who you are. Now, I'm not trying to scare you, but I'm telling you the truth. My encouragement to you is, take this next year and 2 months until you come to this wonderful institution or to another institution where you study to find out who you are. Take this next year and 2 months and find out who you are. Spend time with yourself and ask yourself, who am I if I remove all of the things? What is left? Because remember, when you get to the world out there, people are going to try and define you. People are going to try and challenge your definitions about yourself to fit them. And if you can't stand strong, I guarantee you are going to fall. Guaranteed. I see it every day. Now, this is very deep, and it's much of an allo lesson. But remember, the skills I want to teach you today will help you solidify those things. So yes, let's get back to mathematics. Above your definitions and your axioms are the things that build on top of these things. Theorems, meaning a statement that I've got to be able to prove. Statements are there as well. Conjectures. For those of you that don't know what a conjecture is, that is data handling and probability. I gather data and I predict. Now it sounds, so guys, you do that in everyday life. And how good you are with conjecturing will determine your success in life. Because all of us every day sit in situations where we've got to quickly sum it up. Like a friend comes to you and she is raging mad. You can very quickly, depending on the person, gather information and learn to react. Or you can just react. Your choice. Now at school, it's usually not a biggie. You have a fallout, you don't talk to each other for 5 years. Oh yes, I forgot why we're angry. Let's be friends again. Okay, if it's men, I don't like you. Okay, fine, let's be friends. Okay, that's just how we men work, okay? Ladies, it's a bit of a different story. But ladies, gents, learn to conjecture. Learn to gather data successfully and predict quickly. You can do that. Properties. Now there's 1 or 2 things I would like you to add in there. Formulas, techniques, shortcuts. Those are the things that also form part of the windows and the walls of your reasoning. When we are talking about everyday life, the walls and the windows and the doors are what you see, is the description of you. And all of that, all of the things you say, do, the way you dress, the way you act, all flows out of your definition, your morals, the principles in your life. If your foundation isn't strong, the moment I come with a counter argument, your house is just going to crumble. So I love it when grade 11s and 12s come to me. Sir, I don't agree with you. Please tell me why not. And within usually about a minute, they go, okay, I see your point, sir. I had a student last year who was in the top 1% of the IEB. Got 98% for maths. Brilliant guy. He wasn't the smartest in the class. He was very smart, but there was about 5, 6 guys who should have outperformed him. Every day for about 4 months, 5 months, he would come to me, sir, I'm not getting the answer right. And here's my work. I want to go, okay, what does the law tell me about this? What does the rules tell me? Oh, yes. And then he runs away. Yes. After a while, you're like, okay, I won't answer your question properly. I'll just go, okay. Then the next day, he comes again in between classes. So I'm not, where should you be? No, it's fine. They can wait, sir. Quickly tell me, how do I'm like, but what does the exponential law say? Oh, yes, and then he runs away. He did that every day almost. I love that guy, okay? But every time he came to me, I challenged him just on his foundation and the walls. That's all. I never solved any problems for him. But every time I gave him a blow, he realized, oh, there's a bit of a crack in my walls. Let me quickly fix it, and try again. And then he would come to me, and then I'll hit a crack in another wall. Oh, yes, and then he fixed it. And that made him outperform the smarter guys in the class. Because by the end of matric, his walls and the foundation was extremely strong. We do all of this so that we can problem solve. We do all of this so that we can try and reason things out. If you want to, please, I'm saying it, guys tuning in as well, please be, just take what I'm going to say as what I'm going to say now. If you want to learn how to properly reason and debate, go and check on YouTube. There are guys, there's one guy, for instance, Milo Yiannopoulos or something like that. Now I'm putting it out there. I don't agree with all of the things he's saying. I don't agree with his lifestyle necessarily. He is gay. He's completely against feminism, and he's also for instance, also anti-Muslim and all of those kind of things. So he will offend some of you. But go and look at the way that those kind of guys reason out. He starts, when he goes, I don't agree with this, he starts at the definition. He would say, but you guys, he would say, talk about the feminists. He would say, okay, but the feminist movement was started based on these principles. And then he would go, okay, but in the past years, this is what has started to happen. And this is what has been happening. In this country, this happens. Statistics tells me this. And the people that he's debating against try to go, yeah, but he's like, but what? What can you say against the facts? And they would try and reason. He's like, yeah, but these stats say that. And these guys have done this. And in your country, they've done this. And eventually, after about 10 minutes, it's a catfight, hey? It's just like, these guys, going against each other. But he's unflappable. Because the facts and the things that he built himself up on is so strong. Now, how does that apply to maths? Because I know most of your teachers don't care much for theory. Am I right? They just go, It's not examinable, don't worry about it. They quickly do it 2 minutes on the board and they go, but please don't worry about it, but it won't be asked in the exam. You go, okay, fine. I'll just erase the past 5 minutes of my life. But when you get to varsity, the professors ask you, what allows you to apply that? I remember that very well in my second year. Whole lecture hall like this, bit smaller. We're in the maths department, okay, we don't have like big halls. Okay, a bit smaller hall, 200 actuarial students, actuarial physics or those kind of students. And we are busy doing maths. And this professor comes and we're in the middle of a sum and he goes, wait a minute, how do I solve this problem? We go, oh, but you just apply the formula. He says, why? Why? What do you mean, why? We've always done it since grade 11. He's like, but what allows you to do this formula in this scenario? Well, my teacher told me. He says, well, then it's not good enough. You are not allowed to apply this formula if you don't know why. I got the shock of my life. I had an amazing maths teacher. But I was never worried about why. I didn't care about why if it wasn't in the exam. Your teacher is not going to focus on theory. But my encouragement is, you go and focus on theory. Every single section that you do in maths, make a summary of these things. Start with the definitions, the axioms, the techniques, the formulas, the shortcuts, the theorems, the statements, all of those things. Make summaries on an A4 page for every subsection, like parabolas. Go and do all your theory on one page. So that if your teacher comes to you after the exam and says, but why did you do this? You pluck out your theory and you go, because of this. Oh, okay, now I understand. But guys, if you can't tell the teacher why, they'll just go, but sorry, I'm not going to give you the marks. That's reality. That's vastly reality for you. So before we go to the practice, we need to make sure our house is standing strong. So the next half an hour, 20 minutes, I'm going to try and help you go through the theorems. Okay? I want to go through the geometry theorems with you, give you a few extra side notes, tell you about a few things I know you guys miss out on. I'm going to do my best. You guys ready for this? You guys ready for this? Yes. Okay, ladies and gentlemen, we are going to start off by looking at the basic theories, the basic theorems in mathematics. So I'm going to basically divide all of my theory into 4 parts. Okay? I'm going to divide my theory into 4 parts. The 4 parts, and it's in your booklet, okay? It's nicely all summarized, but it would be nice maybe taking an A4 page, turn it sideways or something. And the 4 parts are pre-grade 11. Then there's going to be one big part divided into 3 subparts, which is for now the grade 11 work, which is about circles. People always ask me, but so why are you so good in maths? Is it just because you're smart? No. Because I know my theory enough, practiced a lot. Now, when I look at the pre-grade 11 parts, those are the part like straight lines, where I've got F, U, N, X, and T. Okay? your three parallel line theorems and vertically opposite, and your angles on a straight line. That is grade 8 work. Then we move, okay, just one thing before I go further to the then part, to the moving on part. Remember, when working with parallel lines, you are not just allowed to say alternate angles or corresponding angles. You have to specify which sides are parallel. You have to. Also, make maybe a side note. Remember, there are only 3 ways of proving lines parallel. If I can prove the corresponding angles are equal, the co-interior angles are supplementary, or the alternate angles are equal, then the lines must be parallel. So if in the exam you see this random question, prove line AB parallel to KM, then I'll be looking to either prove an F, a U, or an N. I can't do it anywhere else. Okay, fantastic. Then when we're looking at triangles, with triangles, first of all, okay, let me not do that. The interior angles are supplementary. All of you guys are with me on that one? That's one of the axioms I talked about earlier. Then as well, if I have an isosceles triangle, then the opposite angles will be equal. Now here's just a nice side note you can make on your notes. This is the first way that I try to use when proving sides equal to each other. So if in an exam they ask me prove AB equal to BC, then that is the first thing I'll look at, is trying to prove the base angles equal. The second way that you can use is congruency. That's a second way you can use to prove sides equal to each other. Don't forget about congruency, please. It's not in the notes, but don't forget about it. 3 sides, side, angle, side, RHS, and angle, angle, side. Don't forget about it. They catch grade 11s and 12s out with it every year. Now, there is a third one that I would like you to put a nice little star next to it. Because you guys always forget about it. That the interior opposite angles, the sum of that is the exterior angle of the triangle. Don't forget about exterior angles of a triangle. Now, I just want to quickly say, I've always had my students struggle with, but so how do I know it's an exterior angle or not? Look at it as if it is a flag. And that is the little stick of the flag that you hold on to. You don't want the flag to look like that or to look like that. You want the stick to be straight. Remember that as well when we're working with cyclic quads. An exterior angle is always one where it looks like a flag, where the line goes straight on. Now, here's something that also you guys forget about. Go revise quadrilateral theorems. Revise all the properties, the definitions, because especially in analytical geometry, they love to say, oh, this thing is a kite. And then in the exam you've got to go, oh, what do I know about a kite again? So please go and make sure that you know your quadrilateral theorems as well. If you don't have it, please just go online, get it, or get an old grade 10 textbook and just photocopy those pages and make summaries for yourself. In grade 11, I have learned to divide my theorems into 3 parts. Okay? For a very good reason. So, what is your name? Yes. Say again? Diego. Okay. What are you going to study next year? Oh, I mean I'm thinking grade 12, sorry. In 2019, if all goes according to plan, what's your plans for studying? Electrical engineering. So you are going to be on that side of the campus. There by stairs, and I think Tribeca is there. Oh yes, we know that, okay. I know it because we always saw the engineers hanging around there. I was a math buff, and so I never saw those places. Okay? You lying in front of the Ola. A beautiful building there. And you're chilling just before, class. And here comes this drop-dead, gorgeous lady. And she comes to you and goes, hey, Diego, my man, how are you? But for the life of you, you cannot remember who the heck she is. Are you going to start going, okay, who did I know again in nursery school? No, it's not in nursery school. What about primary school, right? No, wait, maybe it can be, no. Then high school. Are you going to go through all of those girls? No, what's your first thought going to be? Okay, oh, you are a brave man, okay? Okay, you've lost a few brownie points there. Okay? Your first thought hopefully is, maybe she's in my class. Maybe she knows me from my class. And then if I can't remember them, maybe I go to grade 11 and 12, right? And then if I really don't know that, I go to maybe primary school, but I don't remember much about my primary school. Why am I asking you this silly question, Diego? So because you're trying to be funny, yes. Let me explain to you why. When you are put in that scenario, you don't go and look at all the girls you've known in your whole life. You go and try and open certain boxes and look, maybe she was here, maybe here, maybe here. Look, if I don't look in those few boxes, then I'll ask her. Okay? Why do you guys not do that in maths? When you guys work with circles, I've found the reason why kids struggle with circle geometry is they try and look at all 9 theorems every time they do a sum, and about halfway through you get so confused because there's all of these lines, and then you give up and you move on to the next question. Yes, some of you are going, that's me, sir. Yes, I know. It's my students as well. But please divide circle theorems into 3 parts. Centers of circles, cyclic quads, and tangents. Okay? when looking at centers of circles, what do I do first? Remember my house, I'm going to start at the foundation. I'm going to start by the definition. The definition of a circle gives me radii, and therefore I can look for isosceles triangles. That's step 1, definition. Step 2, I look at theorem 1, which says if I have a line from the center, if it's perpendicular to the chord, then it passes through the midpoint. And the converse, if it passes through the midpoint, it is perpendicular. Which kind of sums can I expect here? Pythagoras. Because for Pythagoras, I need a 90 degrees. Okay, I have seen this mostly with Pythagoras. But also, ladies and gents, that is the third way you could use to prove sides equal to each other. If I can prove I have a 90 degree there, then it must pass through the midpoint. The second theorem, ooh, that one's not good. Oh, I'm struggling with my circles today. The angle at the center is twice the angle at the circumference. Now, I encourage you to use your fingers, even though you might feel like an idiot. You'll be the idiot getting it right. From the center, form that angle, bring it together. From the center, form the angle, bring it together. Understand that there are 3 special cases of this one. The first one looks like that. Angle at the center is still twice angle at the circumference. The second special case looks like that. The angle at the center is twice angle at circumference. The third case, they love to catch guys out. Ooh, that's not nice. The angle at the center is twice angle at circumference. But it's always the one on the opposite circle segment. So, there. They love to ask these 3 in the test. Now again, I use my fingers because when there are 20 lines and 3 circles, it makes life easier. Theorem 3. If I have a diameter, the angle that subtends it must be a right angle. Okay? I want to quickly put it out there. For some of you guys, your teacher would not number the theorems this way. That's fine. This depends on the teacher, because this one is actually a corollary of this one, meaning a special case of this one. It doesn't matter. I break it up into 3 because it makes it easier, and then I remember everything. Theorem 4, 5, and 6 are my cyclic quad theorems. Theorem 4, I affectionately know this one. Oh man. Why am I not getting this one right? Okay. That angle is that angle. That angle is that angle. I affectionately call it the bow tie, but you're not allowed to use a bow tie as your reason. It's angles in the same segment. Theorem 5. The opposite angles of a cyclic quad are supplementary. Theorem 6. The exterior angle of a cyclic quad is equal to the interior opposite angle. Again, a flag. Or the other way, however you are holding the flag, it must be a flag. Again, ladies and gentlemen, there are only 1, 2, 3 ways of proving something a cyclic quad. Don't freak out when they ask that of you. You've then got to prove one of these 3. Theorem 7, 8, 9 are my tangent theorems. Theorem 7. A radius is perpendicular to a tangent. Very important for grade 12 analytical. When I'm working with circles, if I can get the radius, the gradient of the radius, the gradient of the tangent, the product must be -1 because they are perpendicular to each other. Oh no, sir. Yes. This will go over to analytical geometry next year. All of these theorems. Theorem 8. Two tangents from the same point are equal. Very important. Look out for cyclic quads. I mean not cyclic quads, isosceles triangles. Okay? Also, for those of you bright sparks that's maybe seeing something here, what if I connect these 2 points to the midpoint? What do I have? I've got a kite. Okay? But please be careful. You are not allowed to just go, whoa, that thing is a kite. No, whoa. You must first state which sides are equal. And then go over and say, therefore it's a kite. And the wonderful thing is, now you can use all the properties of kites. Diagonals are perpendicular. The diagonals between the non-equal side is bisected. Okay? We love these kind of things. And ladies and gents, I just quickly want to say something. There's a 90 degrees there, right? There's a 90 degrees, right? Oh, but this thing's a cyclic quad. Because the opposite angles are supplementary. I love that, sure. So you are seeing all of these things. Some kind of magic. Okay? I know my theorems very well, that's a thing. And I've practiced a hang of a lot. Theorem 9 is most probably the most important tangent theorem. Theorem 9 says the angle that's formed between the tangent and the chord must be equal to the angle formed in the interior opposite circle segment. Now please, this is the second finger theorem. You follow the tangent, make the angle, bring it together. Follow the tangent, make the angle, bring it together. The same from this side. Make the angle, bring it together. So this one on this side is equal to that one. Okay, let's just do that so you guys don't get confused. This is the one that if you are strapped for time, you look for this. You look for this. Now, ladies and gents, it doesn't help if you just know your theorems. You've got to know, when do I look for these theorems? I look for theorem 1, 2, and 3 when they tell me there's a center of a circle. I look for theorem 7, 8, and 9 when they tell me I've got a tangent. Please be careful. I love it that about a few years ago, 3 years ago, in the matric final exam, they drew a line that looks like a tangent. Yes, and then all my students win. Oh, they did it. It was a matric, it was grade 11 final. All of them assumed it was a tangent. The second question was, prove it's a tangent. Now you've already done the whole first part of the question. By assuming it's a tangent, you get to the second one and you go, now what? Now I've got to start everything over again because I assumed wrongfully that it is a tangent. So tangents you're not allowed to assume. But cyclic quads you are allowed to assume. Not allowed, you must assume it. And we're not going to tell you about it. So please be careful of missing these. Because we won't tell you beforehand, oh look, there's a cyclic quad. No, you have to look for it. And most of my students miss out on theorems because they forget about theorem 4, 5, 6. Not because they forget about theorem 7, 8, 9, because they forget about theorem 4, 5, 6. They forget to look for cyclic quads. Now, ladies and gents, I'm going to be a bit, can I say nasty? I'm going to give you guys that one to go and do it yourself. Okay? This one is in your booklet, so you don't have to try and redraw it quickly. Those guys that's watching on live stream, please try and copy that down and follow what we are doing. So this is on, this specific one, ladies and gents, is on page 26. It's question 10 on page 26. You have 10 minutes. Please go and solve this beautiful question that came out of a matric final exam. Please don't get scared. It's grade 11 work. Okay. So you've got 10 minutes, and please, it's not an exam hall. You may ask your buddy. But first try it yourself. Just some clarity, ladies and gents, at 10.1, the question is calculate E2, angle E2. It doesn't come out very clear. There's about half a minute left. Say again. Okay, ladies and gentlemen, now please, I want to put it out there, way out there, that this is an easy question. If you didn't find it easy, I'm joking, you'll get there. Understand, we are only going to do 2 questions today. I would love to do more, but for me it's more important you understand my way of thinking than just answering a question. I would like you guys to bear with me. I'm going to go very slow, and I'm going to do it with you guys. There we go. Okay, there we go. Fantastic. Okay. Yeah, I'm an amazing artist. Okay? After I've erased 50 times. So, ladies and gents, how do you guys usually approach geometry? Out of experience with my classes. In the diagram below, O is the center of the circle. BD is the diameter of the circle. GEH is a tangent to the circle at E. F and C are 2 points on the circle. FB, FE, FB, BC, CE, and BE are drawn. With E3 or E1 being 32 and E3 being 56. Calculate with reason E2. Okay, wait, let me read the question again. E2. That's how most of you guys approach geometry, am I right? Yeah. And about halfway through you go, just what is this? This is drawn and that is drawn, and guys, please don't. It's going to constantly feel like you are drinking water out of a fire hydrant. Okay? So how do I approach it differently? Little bit by little bit. So it says to me, in the diagram below, O is the center of the circle. Stop. What do I know about the center of the circle? Firstly, I have radii. Do those radii mean anything? No, it doesn't. But I still looked at it. Okay, now let's go further. Theorem 1. Do I have a line from the center of the circle to a chord? I have, but I don't know anything about the chord, so I'm not going to do anything. Theorem 2. Angle at the center, it's a bit iffy. But I can do this, and this gives me 90 degrees, which I would have done in any case when I read that BD is the diameter of the circle, theorem 3, angles in a semicircle. Okay, now I go on to the next. BD is the diameter of a circle. I've done it on my sketch. GEH is a tangent to the circle. Now here starts the fun. I'm telling you, I'm going to highlight a few things here that you didn't see. Maybe. Well, let's start from the top. There. G5 is B1. There. that one is that one. From the bottom, that one is that one. Somebody again. Should I have been able to see all of those? Yes, if you use your fingers. Okay? But please don't forget, have I looked at theorem 7 and 8, sir? No. Do I have a line from the center to the tangent? No. Do I have two tangents? No. So I'm not going to look at 7 and 8. But I've looked at 9 extensively. Okay, and please use your fingers to make sure you find all the ones that I found. Next up, I go and I look for what? Cyclic quads. Because I must look for them. They are hiding in plain sight. So I like to, first of all, always start by looking for bow ties. Not just because they are very delicious Asian dessert, but because it means those two are also equal. It means as well, what can I make this? Just single line. That one is equal to that one. Okay? Now furthermore, I can go and say, okay, I might have a cyclic quad there. So those two are supplementary. Those ones are supplementary. But because I don't have an exterior angle or bow tie, I don't write it on my sketch. Because it's a bit iffy writing supplementary on my sketch. But I must think about it. Now there is another cyclic quad. Whom of you found the third cyclic quad? Ah, 1 or 2 or 3 or 4 or 5. There's a cyclic quad. FEDB. Now I'm not going to highlight that one for this time. But now let's go further. Okay, well, all the other ones just mean that they've got a lot of straight lines. So now they tell me, extra bit of information, that is 32, and that is 56. Now I can go and fill in all the rest. If that is 56, that is 34. If that is 34, that is 34. If that is 32, that is 32. If that whole one is 32, 34, 56, 122, because those, I can go and say, well, those two are supplementary, 58 degrees. So this one is also 58 degrees. Which means these two together are also 58 degrees. Okay, sorry, let's quickly stop. Let's look at the questions. Because I haven't looked at a single question. Oh, determine the value of E2. Oh, but I've got it. It's 34. Determine the value of angle EBC. 66. Determine the value of angle F. But sir, you didn't even look at the questions. No, I didn't. And yet I answered more. I even have angle C. I've got angle D. I've got angle E4 and 5 as well. I have so much more than I need by just going systematically through the theorems. So now the question is, how do I write it down? Well, I would start by saying, okay, well, how did I get that one to be 34? Now I go, what do I know about E2? Guys, look at the way I approach it. I look at the answer. They're asking me for E2. Now I ask myself, what in my theorems told me something about E2? But E2 plus E3 must be 90 degrees. Angles in semicircle. So therefore E2 is 34 degrees. There's my first one. The second one is now I'm looking for B2 and B3. Well, I've got a few choices. I'm going to go with B3 because I need something with B3. B3 is the same as E2, which is 34 degrees. Look at the way I write it. I don't just say B3 is 34. No, B3 is E2, which is 34. Because then the examiner knows what I made it equal to. Not just a value, an angle. And this is angles in angles in same segment. What am I writing? Absolute nonsense, sir. Angles in same segment. Now, why is B2 32? Well, B2 is E1. Tan chord. And lastly, therefore, angle EBC is 66 degrees. My challenge to you guys are, if you are really smart and you're getting really bored in this class today, find more than one way to do this. Find 2, 3, find as many ways possible, because you'll never see this question again. But you'll see a similar type of one. The more ways you can find, the better you are. And the better you'll be for the future. Now, angle C, I'm saying that angle F is equal to angle E1, E2, as well as E3. So I'm going to say E1 plus 2 plus 3. You are allowed to write it like that. And this is 122 degrees. Tan chord. Okay. Everyone all right with that? Any questions about this sum? Is there any of you that the moment that now I ran through it systematically, you go, I missed quite a few things in this? I know, it's fine. It's normal. It's the first time you guys see this. Now it's going to be the second time you guys see this when you do the next one on the next page. Or it's on the same page, just on the right-hand side of the page. Question 12. Okay. In the diagram below, two circles intersect at K and Y. The larger circle passes through O, the center of the smaller circle. T is a point on the smaller circle such that KT is a tangent to the larger circle. TY produced meets the larger circle at W, and WO produced meets KT at E, and W1 is X. So angle W1 is X. I'm going to give you guys 8 minutes. Now, I know that a lot of you won't finish necessarily in 8 minutes, but that's fine. Approach it from the theorems. Approach it as you read the information and give it your best shot. Just a little encouragement for every one of you. Please use colors. Even the men. Borrow colors for now if you want to. Please give it back after you've borrowed. And use colors, especially highlighting things like tangents, cyclic quads, parallel lines. Highlight those for yourself on the sketch. 1 minute left. Okay, ladies and gentlemen, I know that for some of you, you might feel like, but sir, I've barely scratched the surface of this thing, and that's fine. Unfortunately, we are running out of time. We have less than half an hour left of the lesson. Okay? And after we've done this question, I would like to share some exam techniques with you guys. How do I ensure success for future? Okay? So I would like to have a look at this specific question. If I look at this question, ladies and gents, again, I'm going to approach it very systematically. So I'm going to read the information. In the diagram below, two circles intersect at K and Y. Mean anything to me? No. Some of you are waiting for that epiphany, you know. No, it doesn't mean anything. Or not much at least. The larger circle passes through O, the center of the smaller circle. So automatically, I go and look for radii. And because I've got radii, I look for isosceles triangles. Automatically. Before I go any further, I look for those. Remember, I start with a definition and then move out. Theorem 1, yes, I've got a line from the center of the circle to a chord, but I know nothing about the chord, so I'm not going to go further with that one. Theorem 2, angle at center, equal twice angle at circumference. Okay, got that one going. Theorem 3, I don't have a diameter, so that's fine. Okay? Now, I go and say, okay, let's go to the next bit of information. T is a point on the smaller circle with, such that KT is the tangent. So I look for, first of all, theorem 7. Well, it's not I don't have a radius, so there's no theorem 7. I don't have two tangents, so I'm not using theorem 8. So I've got to look at theorem 9. Follow the tangent, make this angle, bring it together. That one is also x, because it's equal to W1, which is x. Okay, everyone's with me on that? Now, next up, I go to the next thing. Ty produced meters the largest circle at W. That's fine. That basically just means this is a straight line. Okay. Now, which theorems did I not look at? Theorem 4, 5, and 6. Don't forget about them. So I'm going to start by highlighting for myself the cyclic quad. Now again, I like to highlight bow ties because Those are the ones that are the nicest. So automatically those two are equal, so that's also x. And because that is x, that one at the top is also x, because they are equal. But now I mustn't forget that a bow tie is not just this way, but turn your head around. It really does feel weird, or turn your book around. And you'll see there's also a bow tie there. So that means that K2 is the same as W2. So this one in here is also x. Ladies and gents, I've answered the first part of the question for 8 marks. 1 mark for statement, 1 mark for reason. 1 mark for statement, 1 mark for reason. Now the second question and the third question. I would like you guys to pay attention to my approach towards the question. Not just the question itself, my approach towards it. It says, prove t equal to 90 minus x. Now some of you guys completely freak out. So where am I going to get 90 from? And where am I going to get x from? Guys, it doesn't matter. Get something that's equal to t. So if they ask me, prove angle K5 equal to B3, start with K5. Get that equal to something. Get B3 equal to something. And in the end, they'll hook up with each other. Don't be so fixated on what you want to prove it equal to. Start with those angles. Now, all I know about T is it is a half of O1 and O2. Or, did I number this correctly? No, I didn't. This should be a 1, 2, 3, and 4. My apologies. So I can say that angle T is a half of O1 plus O4. Now I look and I ask, but how does this relate to x? Because remember, my first question was, get 4 angles that's equal to x. Now I know that O1 plus O4 must be, or well, plus, if I look at this triangle, plus K2 plus Y2 must be 180 degrees. So therefore, O1 plus O4 must be 180, and both of these are x. Therefore, angle T must be equal to a half of 180 and a half of 2x. And there I've proven it. Again, remember the monkey behind the mountains. I look where I want to go, and I look at what do I have to prove to get there. Like in the last question, 12.3, prove KE equal to ET. First option, isosceles triangle. But these aren't 2 legs of the triangle. Second option, congruency. But how many marks does it count? 3 marks. Am I going to necessarily do congruency for 3 marks? No. If it was like 5 or 6 marks, I would have maybe thought about it. But for 3 marks, there must be another way. So therefore, I look at theorem 1. If I can prove this 190, then those two has to be equal to each other. But now I go and ask myself, what did I just prove? Or just not prove for some of you. Not discriminating. Just quickly want to say this. A lot of my students, listen to me very carefully, grade 11s. If you forget everything else, please remember this. Do not get so stuck on 12.2 that you don't even attempt 12.3, that you give up halfway through. Remember, if you've spent 5 minutes on 12.2 and you can't get it right, go to 12.3 and go, I assume t is 90 minus x. May I do that? Yes. Yes, you may. And you can then still do 12.3 even though you couldn't do 12.2. Remember that. Because a lot of my students get stuck at question 1 where they ask you prove something and then they just go, I can't do it. Skip to the next question. But then that was the difficult part. Then the next and the next and the next question was like a walk in the park. But the kids just freak out because they couldn't do one question. Please do not get stuck so much that you don't attempt the next question. Now, I've got 90 degrees minus x. So now I ask myself this question. What does t have to do with E2? Why do I ask myself that, sir? Because look at what I want to prove and look at what I just proven. They have to be related somehow. In geometry, we don't just pop random questions in there. What about a triangle? E2 plus t plus W2 must be 180. Now t is 90 minus x. W2 is x. They become 0. What does E2 equal to? Wow! It adds up to 90. Therefore, the line from the center is perpendicular to the chord. Therefore, the chord is bisected. Is it difficult? Initially, it really is, guys. But the more you practice it, the better you're going to become. So if they ask you in future, prove this thing a tangent to that. Man, just look for the triangle with the base angle. That's what you've got to prove equal for this thing to be a tangent. Or if they ask you prove something is a cyclic quad, man, I look for this to be equal, or I look for exterior angle must be equal to interior opposite angle. So when they ask me prove it's a cyclic quad, guys, I look what do I need to prove equal or supplementary for me to answer the question, and then I manipulate the living daylights out of that thing. Then I look, what is this equal to? What is that equal to? I don't just blindly run into the questions and go, let me write down anything and hope and pray for marks. I make it very clear to my grade 12s. If you write down anything, then you're not going in the right direction. I don't give marks. Not because what you've written down is wrong. You are trying to go to Cape Town, but you're getting on a taxi to Polokwane. Not going to get there. So I don't give marks. Ladies and gents, we're done with the maths. I would like to take this next 15 minutes and talk to you guys about exam techniques. Because I'm telling you now, you can study yourself until you pass out. It will not mean success. Just putting it out there. If you do not have the right exam techniques, I promise you, you can study until you're blue in the face. You are still going to get to an exam and sometimes hit blank. You are still going to, a lot of times, not finish a paper. So how do I prevent that from happening? So let me say this. There are 3 parts in your preparation. Please take notes if you want to. If you just want to listen, that's fine as well. The first part is from now until the day before you write exam. In this time, which is about a month for most of you, I advise you, get together at least 2 Saturdays with your buddies and have theory sessions where you take one Saturday and do the whole paper 1 and go, let's for the next 4 hours eat pizza, get together and have some cool drink, but let's brainstorm about all the sections in paper 1 and write down all the knowledge you guys to combined have about that. Do it the next Saturday you do paper 2, or the Sunday you do paper 2, however you want to do it. Then you practice. You practice, but practice with purpose. What do I mean by that? And I am going to irritate the living daylights out of some of you right now. When I was a tutor for many years, when my students prepped for exams and I let them practice, I would sit with the ruler on the table and do this. While they practice. The most stubborn-headed student would last 5 minutes with this. Usually after about half a minute, my students start freaking out. So no, whoa, that is making me nervous and I don't even have anything to be nervous about. The reality is, guys, when you write exam, that's what's going on in your head. I've got 2 hours left. I've got an hour left, but I've only answered 5 of the 8 questions. Yes, am I writing fast enough? Am I going to finish? Have I studied enough? That's what's going on in your head. Now the question is, can I take it out of your head? The answer is no. But you can make yourself used to it. How do I make myself used to it? At home, put yourself under exam conditions. When you practice, not when you do summaries, when you practice. Number 1, you work against time. Get your cell phone on airplane mode, if you can handle it. If you can't handle your cell phone on airplane mode, get another timer. And work on 1 mark per minute. So if question 1 counts 20 marks, you give yourself 20 minutes and you move on. Because it forces you to think about time when you practice. Now the first 1 or 2 exams you do, guaranteed, you're only going to do about half of the questions. And yes, for some of you, it's going to freak you out. By the 3rd exam you do this, you're going to be used to it. Because you know, I've got to think fast and I've got to write fast. By the third, fourth, fifth exam, I promise you, you're not going to use that timer. You're going to be faster than that timer. Second thing, I'm going to talk again to the ladies. Gents, if you are like this, you can include yourself. When you practice exam papers, forget about 20 different colors. Not doing summaries, practicing papers. Write in one color as you do in the exam. Because in the exam, you're not going to use 20 colors unless you do geometry. You only use blue, black. Okay? That's what you use. And get used to it. The third tip, get used to studying practice exam papers 3 hours at a time. But so I'm struggling to focus more than an hour. My mind starts drifting. Well, in the exam, you're going to have to sit for 3 hours. And you've got to train yourself to get used to focusing for 3 hours. Otherwise, you're not going to have success, guys. In matric, you won't write an exam except maybe if it's Afrikaans or a language or maybe one of the other subjects. I want to say the smaller subjects. You won't write an exam that's less than 3 hours. Get used to sitting on your backside for 3 hours straight and practicing. It's the only way you're going to get used to it. Now, the day before the exam, please go to bed normal time. I know it's tough, but rest is more important than an hour or two worth of extra studies. Because if you're going to be tired the next day, you won't be able to think clearly, which means that you're not going to be able to solve problems. Put away your books, cell phone, technology, 1 hour before you go to bed. And go and do something that's out of the ordinary. Go and drink a cup of coffee with your parents. Go and, you know what, lie under the stars if it's not raining. Okay? Don't get pneumonia, please. Won't help you. Okay? Do something that relaxes you. Otherwise, you're going to lie in bed and go, yes, what does this theorem say about this again? You know, did I study that hard enough? What did I do again in this section of work? And it's going to go through your head the whole evening, which means you're going to get 2-3 hours less sleep. And why do I say put away technology? It's been proven that if you use technology before bed, your senses do not switch off. Proven. The stimulation to your senses is too much. Your mind, your eyes, your brain don't shut off properly. That's why some of you are not getting proper sleep at night. It's been proven, scientifically proven. Now, ladies and gents, what about the day of the exam? That, when it's crunch time, because I want to just quickly make it real. Whatever you do for the next year and 2 months is going to determine where you end up in life. It's going to determine which degree you can go and study. It's going to determine whether you're going to get bursaries. It's going to determine whether that dream you've always had since you were yay high is going to come true or not. So it's crunch time now. Not putting extra pressure, but that's realities. That's realities. Running away from it, you're going to be stupid, I'm sorry. Face the reality and let's see what we can do to overcome the realities. The day of the exam, please, that 10-minute sleeping time, I mean reading time, use it wisely. Take a question paper. and classify the paper according to easy, medium, and what the hell. Because there's always those questions. And sometimes your teacher or the department, whoever sets up your papers, throws those what the hell questions in the middle, and it completely derails you guys. Completely make you fizzle out. So how do I overcome that? Number one, start with the easy questions. Even if it's question 10, but your teacher might not like it, but keep the whole question 10 together. Keep it together. If you are a bit OCD, it's fine. Do one question on a page. And then later on, compile it nicely for yourself and staple it together. But your teacher's not allowed to penalize you as long as you keep the whole question together. Start with question 10, then you do 5, then you do 3, then you do 8. Then you move over to the medium difficulty questions. Then you go over to the really what the hell kind of questions. Guys, I say that to my students, and my colleagues hate it because it doesn't make marking easy. But I'm not allowed to penalize. As long as I clearly indicate big on top, I'm working with question 6. They're not allowed to penalize you. Why do I tell you to do this? Number one, self-confidence. If you start with question 1 and it's a difficult question, you start hyperventilating. I haven't studied enough. I haven't done enough. I can't do this maths. And you hit blank. If you start with question 6 and it's easy, and then you do question 8 and it's easy, what do you start telling yourself? I can do this thing. I've got this down. I can get my distinction. I can get my 90. I can get my 60 if that's you. I can do it. Then by the time you get over to the medium difficulty questions, you go, it's fine. I'm thinking clearly. I've got confidence. I'm boosted because I've studied. Then when you get to the what the hell questions, you go, let me knuckle down and think about it. Because I've already scored all of those marks. I've already done. Now I can knuckle down and really do this. But also, it prevents the epic failure. You hit the last question, 15 marks, and you go, yes, I know how to do this. 5 minutes left. Let me write down, wow, okay, and then you mess up that question, and what do you do when you walk out? Why did I do this to me? I know I could do this. But guys, if you hit the last question, and it's a really what the hell kind of question, and you've done the whole rest of the paper, you've scored the marks, you've done the medium difficulty questions, you've even done most of the what the hell questions, and they tell you 5 minutes left. Nah, whatever. Let me write down what I can and score as many marks as I can, and then I'll move on with my life. Ladies and gents, you're going to walk out of that exam going, I've nailed this. And that, remember, is important because you've got a whole exam to consider, not just one paper. Ladies and gents, your future is in your hands. Make the most of it. If you've got those dreams that you want to go for, give it all you've got and make yourself proud. It's been an absolutely awesome week. It's been an amazing privilege for me to be here. Go and make yourself proud, ladies and gents.